with respect to our servers, what things are the most notable in terms of emissions that you would be concerned about in testing to? What problems do you frequently find?
A lot of the problems that we find are the conducted emissions.
Okay, CE.
Correct. We've got a lot of design experience in the actual physical build, if you will, of our servers that we can eliminate a lot of the radiated emissions. So conducted is still our biggest issue. The reason that is because we use a lot of COTS, commercial off-the-shelf power supplies, which we don't have control of how their emissions are being generated, and so that's where we have.
Okay. Well, once you find that situation, what kind of what do you do to knock down that problem in terms of conducted emissions?
So for conducted emissions, we design filters that go between the outside world and our power supply. I wish I had one to show you, but we design them to specifically match the requirements of a specific power supply. One thing that you run into in power supply design or using COTS power supplies is that most of the supplies that we use are designed and tested to FCC requirements. FCC typically only cares about going down to about 150 kilohertz. We test to mil 461, which takes us all the way down to 10 kilohertz. The main switching frequency on the front end of a power supply is typically in the range of 60 to 70 kilohertz. Well, you can see for FCC, if you don't care about 150 kilohertz or below, well, that 60, 70 kilohertz is out of the range, but it's right in the middle of our lower end.
And we'll throw up some examples of CE 102 testing where we were below the line in this example, and then in the next example we'll throw up a graph where we're really up above the line in three places, and so you can see essentially what had to be done to knock the conducted emissions down and what kind of filter had to be designed. And I guess the interesting thing about this, Matt, is not every filter works for every application, right? Sometimes you've got to tweak these depending on what you're powering and the power supply that you're working with.
That's correct. All of the power supplies that we buy have an EMC filter built into them. In order to get to a lower frequency or get lower frequency cutoff, you need to go with larger size components. What happens if you put a small filter, so you've got the noise coming out of the unit. If it's being filtered by a small filter and then trying to be filtered by a large filter, you can end up with the filters fighting against each other, and they actually create peaks that are worse than if you didn't put that big filter out there. So we can tweak our off-the-shelf power supply filters to knock that noise in the 60, 70 kilohertz range down, and then we can put a smaller filter out in front of that to knock down the higher frequencies.
So we talked a lot about COTS power supplies. One of the things that we should probably mention is we do custom power supplies too, and in that case we kind of have a pretty good head start on understanding what needs to be done to create the filter.
Right, and we can design that filtering from the get-go. As we start the design, we're aware of the current loops and so forth that we need to watch so that we don't end up with